IMK 225 Liquid-Liquid Separation. Let me introduce to you our group members. Hello, I am Afika.
I am Hidayah.
I am Tan Zining.
Hi, I'm Miao Ning.
And I am Adriana.
So let us start by explaining the definition of liquid-liquid separation. Liquid-liquid separation is a process where two liquids which are immiscible with each other due to their incompatibility in intermolecular bond types, and thus results in the two liquids being completely insoluble in each other to be separated into two liquids phase. The most common example is oil and water. Both oil and water are insoluble in each other. By using liquid-liquid separation methods, the mixture of both oil and water can be separated. There are a few methods commonly used in liquid-liquid separation, and today we are going to discuss three of them, which are centrifugation, liquid-liquid chromatography, and lastly, distillation.
Centrifugation is used to separate mixtures of two or more phases, one of which is a continuous phase. Centrifuge machines have few main components, including the rotor that will spin around a central axis and exert centrifugal force. The centrifugal force exerted will move particles away from the axis of rotation. In the centrifuge machine, the particles are suspended in a liquid medium and placed in a centrifuge tube. Then the rotor will spin at defined speed. The centrifugation is influenced by density and viscosity of solution or samples, size of particle, and rotor speed. There are two very common rotor designs. The first one, as shown in the clip, is fixed angle rotor that is designed to hold tubes in a fixed position. The second rotor design is swinging bucket, which allows the tubes to swing out from a vertical resting position to become parallel to the horizontal during centrifugation. There are two things that need to be considered when using centrifuge machine, which are the mass of the sample load must be balanced to be put in the rotor and must be put in the opposite direction if only two samples are used. For example, centrifuge is used in a skimming of milk, where skim milk is the continuous phase and the fat phase is the discontinuous phase in the form of fat globules. This process will separate the cream from the skim milk.
The next method that involved in liquid-liquid separation is liquid-liquid chromatography, or is known as LLC. LLC combines the separation principles of liquid-liquid extraction and chromatography. There are two important mechanisms involved in chromatographic separation, which are adsorption and partitioning. The basis of liquid-liquid separation in LLC is to partition solutes between two immiscible liquid phases. In LLC, users prepare both phases, mobile phase and stationary phase, by mixing two solvents that form bibasic system. One phase being the mobile carrier and the other being the thin liquid layer supported on the inert stationary phase packed inside the column. Firstly, the column is filled up with stationary phase and the column is spun. Then, the mobile phase is pumped into the stationary phase. When the mobile phase comes off from the column, the equilibrium between mobile phase and stationary phase has been reached. Sample is loaded and injected into the column. Then, the detector is switched on to detect and collect the results. Then, the chromatogram is used to identify fraction and analysis. Actually, LLC is quite similar to the separation of two immiscible liquid using conventional separating funnel. However, the concurrent extraction process as the mobile phase travel down the column is more effective than the separating funnel. It also results in clearly defined isolation bands, which is detected using suitable detector.
The last method we discussed is distillation. Distillation is the process of separating the mixtures of the liquid based on the differences of boiling point that is required to change the phase of the component of the mixture. The compound with the lower boiling point will become a vapor that we can collect it, while the compound with the higher boiling point will remain as a liquid in the distillation flask. To separate a mixture of the liquid can be heat to a false component which have different boiling point into the gas phases. The gas is then condensed back into the liquid form and the liquid form will be collected. Distilling flask which contain the mixtures of the liquid will be boiled in the hot water, where the vapor will then travel up into the side arm and continue in the condenser with the aid of the cold water. The cold water will cause the temperature of the vapor decrease and change the phase of the vapor to liquid, which called distillate and which will be collected at the end of the experiment.
As conclusion, liquid-liquid separation is important to separate two or more different liquid from a mixture. This method is significantly used for research and chemical analysis, especially in environmental, clinical, and industrial labs. Every process comes with their own advantages and disadvantages. Advantages of liquid-liquid separation include simple operation is used in the process and simple apparatus is needed in conducting the process, while the disadvantages of liquid-liquid separation are a large number of solvents of high purity is needed to be used. Thus, it may lead to the increasing of environmental pollution. And this process is a tedious one and it's also time-consuming.